Hello, I think we're live now. How is everyone? Welcome to the stream. Welcome to yet another Rust stream. Well, we're gonna be doing a little bit more of the same stuff that we did in the last video. So basically, we reworked the way that we store links internally in our web crawler, and what we want to do now is to have a way to serialize those links into JSON in a way that's not really kind of loading all the links into memory, because we might have an issue when we have a lot of links, right? So I thought I would work a little bit with the Serde library today and kind of see how we can do like a stream serializer or something like that. I do apologize, I'm not feeling too well today. I got a massive neck pain, so I can't really stand straight here. I can't sit straight. But yeah, let's go into it. So let's open our Visual Studio Code. This is basically some code where we left off from last week, with a few minor changes. I think I was actually using this repository to create a GitHub CI, a GitHub Actions workflow to essentially build everything automatically whenever we have a push to main, or a pull request created or something like that. And yeah, I mean, I have changed it just slightly just to fix the pipeline in terms of like code formatting and static analysis, but everything should still be the same as it was last week, right? And if we remember very well, what we actually did last week was I believe we changed this link structure here. So essentially, every link is represented by a link ID. I guess it has a URL as well, and it has children and parents. So like the children is essentially a list of other links that are contained within a web page, and the parents are links or other web pages that link to this particular link, right? And yeah, so that's kind of what we did, and we refactored the way that we're storing, or we're gathering those links and representing them in a map. I think if I look at my main or my crawler file or something, there is the crawler state. The crawler state is the struct where I store the entirety of the crawler state. So like the links visited and the links to be visited, the links queue, and also the link IDs. The link IDs is just a way for me to kind of say, you know, this URL is represented by this particular link ID here. So it is a little bit of, I guess, duplication, because we essentially have the URL stored in the link itself. And there's no definition for link. That's interesting. Why is Rust Analyzer not working? Failed to no such file directory. This is so weird, huh? I have no idea why cargo isn't building. So for the cargo build, yeah, I just noticed that my Rust Analyzer isn't running, so we can't get into IntelliSense. Cargo is working fine. Maybe it's just a Visual Studio kind of thing. Let's see if I can restart. So Rust Analyzer, restart the language server or something like that. Nope, it's just for some reason not working. No such file directory version. cd python Rust. Yeah, for some reason it thinks that we have some kind of like old version of the code, because I did move everything to the root directory, because we had the repository, and then inside the repository we had a directory called Rusty Crawler, and then inside there we had the cargo project. So I just moved it up once, and it seems like the Rust Analyzer web server still thinks that we have that version of the code for some reason. Rust Analyzer restart server doesn't work, so if I clear cache or something like that, maybe Is that a thing? Maybe not. Can I delete the cargo lock? Is that going to make a difference? That is interesting. Right, let me see what's going on, because it's definitely a path file. I can see it here already. So you see that, you know, it expects a rusty crawler inside rusty crawler, and we don't have this inner kind of directory now. By the way, guys, if you're watching this for the first time and you've not yet subscribed to the channel, feel free to subscribe and keep up with with all the videos that I release. Okay, yeah, let's try and open the folder again. That one. Or if we reload the window, maybe. Yeah, my neck pains are just the worst. Okay, so is my Rust analyzer working? No, it's still it's still kind of thinking we have rusty crawler inside rusty crawler. This is ridiculous. Yeah, this is kind of messed up. So it's loading the old repository for some reason. Rust analyzer is, and I have no idea how to kind of undo that. Maybe it's here. No, we've only got settings.json here. Ah, here we go. Here we go. If we remove that, right? Or in fact, if we just do that. So it's a setting inside VS Code. Interesting. Very interesting indeed. There you go. It's working now, isn't it? Yeah. Yay, it's working now. Cool. Now we can continue with the video. I'm going to close all these pipeline files that we don't really care about anymore. So the first thing I want to do in this video is to take my list of links that we have visited and serialize them to a JSON file, which we kind of already do anyway. Like there is a Serde JSON call. However, it kind of serializes everything into memory, right? So I basically have to have a converted version of my links into a map, essentially, for it to serialize everything. And I kind of want to see if it can do, if it can take my original, I guess, like map of links, essentially, and just store them in a file, like one line by one line, like maybe a link by a link or something like that. So let's see if we can do that. Rust analyzer is still going. Failed to discover space. So let's. Can we restart the server though? Clear output. A second, I'm just checking some. Okay. Yeah. Okay. So all my dependencies were acquired here. That's good. yeah, so let's firstly look at, you know, how we can do that. So Serde, we've got a stream serializer. I actually have Googled this before, and I think I did it on stream, but we didn't actually implement this. So there was a particular solution that I wanted to kind of follow here, and it's this one here, right? Where we pass in a, I guess, an output iterator or something like that to the Serde serializer to create a new Serde JSON serializer, and then we kind of serialize each row at a time. So this would be a good contender for a solution that we want here, and in fact I think most people liked it. But to get there in the first stage, I needed to implement some traits, right? Because yes, we're going to have a serializer for JSON, but I also want to allow the serialization to happen into databases, or maybe SQL databases, or even something like a NoSQL database like DynamoDB, right? So these things can be, I guess, achieved via different structs that implement a common trait, and the trait will say, you know, which functions exist for serializing that particular link, right? So that's what we're going to do here. So the main thing that we want is some sort of trade, like here. So this trade to allow the link graph type to be serialized. For the American spelling, I guess. And all that we're going to have inside the trade is obviously a function called serialize, and then that will take the links graph, I guess a reference to it, actually, and then returns a result if it succeeded or not, right? So in fact, this is kind of what we want at the very top, maybe here. Oh, maybe just here is fine. And yeah, we can kind of have, I guess these are models, so we can maybe have something like a new module called serializers or something. Yeah, I think that's going to be cleaner, right? So let's kind of create a new folder here called the serializers, or model serializer. Yeah, serializer will do. And do we need a mod.rs? Probably do, yeah. So mod.rs here, and I'm just gonna copy and paste these things so I can kind of do something similar. Obviously I don't have that, and I also don't have that. Let's say we have a file called serializer, so JSON serializer here, and that's where we're going to store the JSON serializer, right? We're also going to have a module for the traits serializer, or trait serializer. And then we can do something like, you know, JSON serializer here, and then we publicly use all the serializer traits. So there you go. So we kind of want to use want to create these two files now. So a JSON serializer.rs and a serializer traits.rs as well. As you can probably guess, the serializer traits is just where we're going to store all the trait related definitions, right? Which might actually be quite small now, but yeah. And then we also have a new file called the JSON serializer. So the idea is whenever we implement these traits, whenever we implement one of these, I guess these serializers, to implement a new one, for example, a database, a SQL or a NoSQL serializer, all we have to do is to create a new file and implement the necessary traits. But obviously inside those files we're going to be calling something like a SQL driver or something like that to insert the data into the SQL. And likewise for the DynamoDB, we're going to be calling like the Amazon crates or something like that to connect to Amazon, and then push the link data to a DynamoDB, right? So obviously we're not going to get into, probably not going to get to the SQL stuff or the NoSQL stuff today, but that is it's good to keep it in mind that we want to extend this in the future, just so we don't sort of hard code things too much and make things really hard to extend. But yeah, so I'm actually going to move some of this, like this particular trade here. This should go inside this trade here. Okay, so this is the link serializer. And obviously we can have other serializers here too. So we have maybe the image serializer where we save the JSON for the images. These can all be in here. And yeah, so let's take a look at what we had in the, I don't care about this for now. Yeah, I'm just going to take a look at what we had in the graph, because there were still a few things that we had to refactor and implement here. So for example, for a link graph, I provided a function called update, and update was essentially just taking the URL and you know, the discovered children, and kind of like updating the internal data based on what we found here. So for example, the first case here, I left a very helpful comment. So if we already have the link here, we simply need to add the children and the parent. Okay, so if the link already exists in the links, I think that's what I meant, right? So if links dot okay, so we do probably want to put this here, there, and there. Okay, yeah, there you go. Obviously we want to return an okay here or something just for now, so it stops complaining. Oh, it already does. Yeah, so if that links kind of what's the issue? If links, oh, okay, yeah, so you kind of want to take a self here, which is wait, how do I take self again in Rust? Oh gosh, this is embarrassing. Yeah, so I know that the capital one is the class and the little one is the actual instance. Okay, so we take a self, yeah. There you go. That's what I wanted to see. I was right in the first place, but self.links.get, I think it is. If it already has the URL, in other words, if this is, I guess, you know, let's do let this link equals that, and then let's get a mutable version of that, shall we? And update is obviously going to take a mutable version of self as well. Okay, or now the thing is, we don't really want to return an error here, right? So what do I want to do? I want this link to be a mutable link, definitely, which will either come from the, I guess, the array of links that we have here, links.get, and then we have the key, which is the URL, or in fact, not even that. So we have the link IDs, right? Yeah, so let this link ID okay, I see, yeah. So this is where we're going to keep track of the links, link IDs. just thinking of a way to safely have an increment for this, right? So U64, right? Yeah, so we probably need something like a const or a static here. Atomic U64. U64. Yeah, this is what we have the counter. The reason why I'm creating this counter here, this atomic counter, is because I want to keep track of which one was the last ID so I can increment it, right? Every time I create a link. So that's the idea. That's the idea here. And why does it need to be atomic? Well, because we're going to be doing this from a few different threads, possibly, because we have different Tokyo workers that will be actually getting links, right? So they will potentially run on different threads. So this is why the atomic here. Yeah, so that we're kind of ready to go. So link id counter dot fetch add will be the one. So added by one, and then we've got ordering. Seek std. These are the same as the ordering stuff in C++, so if you're interested in knowing what that is, feel free to go and read it. It's on the C++ reference, I think. Is this gonna work? There you go. Yeah, so essentially this is going to give me a new sort of incremented link every time. But I only really want to do this, okay, if I guess we fail to get the current link, right? So for example, if links IDs has a self.link IDs dot get, and then we have the key, which is the URL in this case. Yeah, let me rethink this logic a little bit. So what do I want to do here? I want to get the current link ID or create a new one, right? Yeah, okay. So basically here, I want to have this link ID. Okay, and where was I? So I want to say that if let some link ID equals to this, then we're going to return what we should return. Else, we're going to return this. That's what we're going to do. So we're going to create a new link in here too. So then we want a link new, and what do we take here? So we take a URL. We take a children, so I guess the children will be here, which is a vector of string. So we should take, wait, what? Oh, okay, so let's keep this as default for now. We will update the children later, right? We can do that. So the parents, again, default, and vector of images again. And the titles. Okay, right, so this should kind of work, right? I guess. Kind of feel like this would be easier to just manually create yeah. If I just did this instead, I think it would look a little bit more gracious. So if I do like URL equals that, and then the rest is going to be default. That works, right? Yeah, there you go. That's what I like about Rust. You can default everything else. You can set one thing, one of your attributes in a struct, and then the rest of it you can just say default, and it will work. Of course, if those types support the default trade. But cool, yeah, cool. That was delicious. Yeah, so in this case here, I either return the link ID, or we kind of return, you know, we add new link to the map, return its ID. This logic may be a bit complicated, but it is what it is. So yeah, so I guess with self.links, and then we kind of have to add it, insert here. And insert is interesting because if the map did not have this key present, none is returned, right? If the map did have this key present, the value is updated. So basically we want it to return a none. If it returns anything other than none, it should be an error, right? So if we insert the key, which is this, the new link ID, and then the link itself, new link, we want to make sure that this is none, right? And then we want to return an error if not. Let me actually close this annoying Steam. Sorry about that. Please don't add me on Steam. Yeah, so is there a function in Rust that kind of just, you know, map? Yeah, I want to turn the none into something, if it makes sense, and then map it to an error. Rust map none to error. Map none to success, I guess. So return error if option isn't none. So Rust return error if is some. That's going to return error if option is some. There you go. I assume this is about having it to be a single line and saving characters. I guess it is, right? I just wondered if there was a sort of like a syntactic sugar function or something like that. Oh, this guy creates a trait here. Interesting. Okay, so it seems like we can do a map or, right? So map or returns the provided default result if none, or applies. Okay, so okay, that or applies this. Actually, I should have just kept that page because I kind of missed it. Yeah, there you go. Yeah, I was wondering, we don't really care about this, right? So oh no, we do want a none here. So okay, map or anyhow. Yeah, so this is kind of what we want. So we want to basically, after we create a new link, we want to attempt to insert it, I guess, right? Because it could fail. And if it doesn't insert, then we know there was already a link with that, which is an error for us because we kind of know there should be no link with the same URL in our links page. Sorry, our links database. So anyhow, does this work? There you go, yeah. And yeah, this is all of this here, all of this, just to essentially get a link ID. Regardless, get a link ID, right? So I think we should probably put a, a function here that will just do that thing. So we just separate that code into a function. So let's do that. So fn, so we, I guess, acquire link ID, get link ID. So, but what we're doing is like force get link ID, right, for a particular URL, which is a string. Or do we want to kind of get the link anyway for this? Yeah, I guess we can return the link itself, right? So a mutable link. Can I return a mutable link? A mutable reference to a link? Is that valid in Rust? I think this is why we get into lifetimes, right? So we have self as a mutable there. Hopefully, and yeah, as you can probably guess, copy all of this thing here. At this stage, we should already have some kind of kind of link in here, right? So that's what we want to do here. Oh gosh. I guess we can just return this, right? There you go. That's the same thing. Yeah, so this is... Ooh, enum takes 2 generic. No, it doesn't. It does not. Because I'm not using... I'm using this result. There you go. And what's the issue here, though? If and else having compatible types. Expected U64 and found nothing. Ah yes, it's because we don't have the, you know, new link ID here. Why is this failing? The trade bound link default is not satisfied. The trade default is not implemented by link. No worries, we can do that. And what's the default function again? I guess, yeah. I mean, we don't need to implement it. We can just put it here. Now the link. That's why. I already had a link counter here, so I don't need it on the other page. It's useful to know. But anyway, yeah, let's implement it because we actually need to properly implement the default in this case. What is it? Function default, which returns a link. I think that's it, right? Yeah, that is it. But the issue is we need to return some actual valid things here. So the default is actually going to do the link counter fetch add here by 1 and then ordering sec. Let me also make this a little bit prettier. So the URL empty, I guess, right? Yeah, we can leave that as it is for now. So in fact, string from that children default. There you go. So this will be our default function. Yeah, the new link ID, we kind of don't even need that right now, because all we need to do is create a new link and then just return the new link. Yeah, just return the ID here. And there you go. So that should hopefully work. Expected U64. Yeah. There you go. That's better. Good. So we've got this force get link. Let's just put a little documentation here. This function will retrieve a valid link ID if the URL is already contained within the links map. Otherwise, we will create a new link and add to link with the given URL. Oh my god, I can't. There you go. And add it to the list. Okay, cool. And why did we put it into this function? Because we just want to put it here now. We just want to kind of get, let mute. And we kind of want to do a self, is it force get links, there you go, with the current URL. And then we kind of want to just let that be the link. Not sure why there was two selves. And if it, for any reason it failed, we can just pass the error up the stream. Yeah, all of that just to get a valid reference to a link here. But we'll get there. Okay. So once we have the link, what can we do? So the parent ID is already exists, then add parent to the parent list. Okay, so if, I guess the logic here was the following. So if the parent, so the from should really be here, right? So parent or something. If parent already exists in list, so how can we do that? Self dot link IDs. No, get parent, I guess. So if this is an actual value, which means you have to do an if let here. So if some parent ID is equals to that, we can kind of do link dot parents. I think it's push. Yeah, push parent ID. Okay, good. So for each children, okay. So for each children, this is what we do a for loop, I guess, for a child in children. It's a reference to a string. We kind of want to do the same thing here, the same thing as we did with the parents. So if some child ID is equal self the link IDs dot get child, then we just say link dot children push, and then we say child ID here, right? And we've automatically dealt with this as well, because this is the case where we didn't have a link in the first place, which means we create one. Okay, so that's it. That's it really. So like for each child, then add their ID. To this links children. And there you go. Now, how much better is that to read? Much better, right? So good, good. So essentially, I can call this kind of like update function whenever we're adding new links in the code. So iterator for link graph. We don't really want this right now, I don't think. Or do we? Or do we? Yeah, I think we do. So self. Are we even using this link counter there? No, we're not. So we can remove that. And also remove the atomic thing in here. There you go. Much better now. And what's the issue in this particular one? So derive default. Yeah, we don't want to derive default anymore. Parent ID found U64. Okay. Can I just do it into? Or do I have to actually clone? Yeah, no. Into doesn't work like that, I guess. Child is a string of a string. What the hell? So the trait bound by string. Borrow is not satisfied. What the hell? I think this is because it's a double string here, right? Clone works, but why? I can't explain why. Does into work here? No, it worked. How do I do that? How do I remove the double reference? So I've got a reference to a reference of characters. So first remove double. Okay, no, this is, I know why we get it, because it's initially a reference. And the children, when you do an iterator, you get a reference to the element, a reference to a reference. That's what we had in the first place. A vector of references. But I just want to know how I remove that. I mean, this guy's saying there's nothing special about it, but clearly there is, because it doesn't just kind of treats it like a normal reference anyway. But whatever, you know, clone it, we'll fix it for now. So child ID, what is that? So push, and then clone here. Okay, clone. A lot of clones, and how do you feel bad about these? Yeah, my update method allows us to set the string, the children, and the parents, right? I don't have any images or titles there. So let me change that. So we take in the images too. So we've got images, and then we have a reference of images, I guess. And then titles, or just image, in fact. And what else was in link? A vector of string, right? So links. Or we can just be this as well, I guess. No, not links. What is this? Titles. Yeah, sorry. And I'm just thinking to myself as well, I'm extremely kind of thinking of moving this children and parents here to a set, because right, you can go to the same link through different pages, right? So you can go to my web page, for example, margomez.com, through my GitHub. You can find it through my GitHub, or you can find it through my YouTube account. So you're going to be visiting it twice there. Yeah, so I'm just thinking that maybe we'll have duplicated children and parents, but that will depend on the way we call this update function, like when we call it, whether or not we're checking if we've already visited the link, basically. So yeah. Yeah, so I'm kind of worried about that now. But let's not care about it for now. Right? Let's not care about it for now. I am going to post a comment here, so potentially, there's a chance that we might visit the same link for different parents. Meaning that we will get duplicated children, images, titles, right? So we need a way to sort of unduplicate all of this, and I use sets, right? Sets will be a good data structure to do that, because even if you add it twice, if you don't care about actually adding it multiple times, unused.comment user. Okay, yeah, we'll do that. That's fine. So we're just going to ignore that for now. We do, however, want to not ignore, I guess, if we have the links, we have to set the images dot extend images here. We can do that, right? No, we cannot. Why can't we not? Mismatch type, resolve an image, found the image. Okay, so Will this work? Yay, it does. No, it doesn't. Expected image found image. Intuitor will do, right? So hopefully Intuitor will copy everything. No, it does not. There you go. Yeah, we're going to be copying all the images. It's not a problem. We should probably, you know, kind of reduce all these cloned things as well. A way we could do that is by just moving the vector into here and then just kind of setting it to, you know, yeah, we can do that. Maybe use and then we want to change the kind of link dot the titles as well, right? And it's the same thing, so we do the titles, like him in, it's a dot cloned. There you go. Or maybe not. Right, I'm lazy, so I'm gonna do this. There you go. Good. So this function should kind of work for us. What is anyhow? Expected enum result found anyhow error. Wait, why? Expected a result and found anyhow error. Try wrapping the expression in an error. Okay. Does that work? Does this work? No, it still doesn't work. How do I create just an error type? With anyhow. Maybe what we have is fine, and if we just follow what the compiler says, it should work, right? Right? Yeah, it does. Ah, yes, because in here I actually need the new link ID. That's correct. And it kind of has to be that, I guess. What's the issue here now? Can't find link ID in the scope. Oh, it's because it's this link ID. Slim, hey man. Good evening, welcome to the stream. How is it going, dude? How is it going? Okay, cool. So that should work, right? What's the issue here though? Expected method next has incompatible type. So it should be a mute. Okay. Does that work? So links next. No method found next for hash map. Very ill right now. Oh dude, yeah, there's a massive wave of COVID, right? Going around the UK. Hopefully it's not that. I feel like everyone I kind of work with in the past week or two have gotten ill. So yeah, I managed to dodge it so far. So hopefully I'm not gonna get it. I'm a healthy boy, but yeah, I hate being ill, dude. Absolutely hate being ill. Like having to stay on the sofa all day or lying down. Not being able to do like any exercise or go out to the shops or anything like that. It's kind of shit, isn't it? But you know, I hope you get better, man. Let's hope you get better in the following days. Make sure you're treating yourself well. Make sure you're eating soup and taking medicine and stuff. By the way, how do you stay motivated? Ooh. It's difficult, man. Not gonna lie, it's very difficult. And get motivated to grind at home. Yeah. Basically, I enjoy doing this shit, to be honest. I enjoy like coding on my free time. I enjoy coding at work as well. That's another thing. But I do go through sort of like periods of being completely dismotivated, like unmotivated. In fact, if you look at my YouTube channel, you can kind of tell when that happens. So I'm not always motivated, man. But yeah, like I had no motivation for like a month and a half after this video here, so I didn't do anything. Oh no, I did. I was doing the streams. But then before that, this is where I didn't really post anything. So I wasn't really learning anything on my free time either. I was basically just playing Counter-Strike 2 all the time, and got into a very bad habit of just gaming. But yeah, man, I kind of, now to stay motivated, I kind of just try and think of the bright side of it. Like the more stuff you do now at this age, like the more you learn, the more experience you get, you know, the better, you know, sounds a bit cheesy, but the better future you're probably gonna have. Like you're gonna know more stuff at the very least, right? Which is definitely a good thing. Now for the YouTube side of things, like my motivation is, I guess, just to, at the moment, just to help out people, but do it at my own pace. Like I don't really, I don't post something like every 2 days like some of the professional YouTubers out there. Like I like taking my time to read into things, to learn how to use a particular tool or a technique that I'm talking about. If you know what I mean, that's kind of like how I do things. But yeah, it's very difficult, man. Especially when you're ill, you see. If you're ill now, staying motivated is very difficult. You just want to kind of relax and stay in bed and stuff. There's nothing wrong with, you know, not being motivated all the time. Not everyone is motivated all the time, by the way, no matter what people tell you. Like everyone goes through you know, periods in their life where they have no motivation at all. Maybe because you're going through something personal, or I don't know, not enjoying work or something like that. You know, you've seen a lot of people around you doing well, generally kind of brings people down a little bit, I feel. Like definitely happens to me, or has happened in the past. So yeah, just ill currently, yeah. Sorry, I went too deep there. I thought you like really asked the question, if you know. I thought you really asked the question, but yeah, you're just ill, bro. That's fair enough. Right. I can't implement this iterator thing, so let's scrap that. Actually, no, I want to implement. I want to learn how to do this. How do I implement an iterator for this type? Implement proxy iterator in Rust. Because I have like these links, and I kind of just want to say, yeah, I kind of just want to pass down my iterator to the links. If no method. What? Oh, Antonio, hello. Olá, meu amigo. How is it going? How is it going? Do you guys know how to do this? So I have like, I wanna implement the iterator type for my struct type link graph, but that has a an attribute called linked, which is a hash map. And all I want it to do is to essentially have the iterator go through each link here, so the values, right? Apparently doing this doesn't really work. Doesn't really work. So I wonder if it's... So next doesn't exist. Does iter? Does that work? Self item. Do values work? Yeah, iter won't work, right? Because I guess if you actually look at the type that it returns, so hello, this will be like a key value pair, right? Yeah, there you go. U64 links. But if I do values, maybe values will work. Iter then collect. Not quite, because like the type that should be returning from this is just a link, but link is the kind of the value type inside the map. So if I just do iter, it will bring both key and value together, right? So links. Yeah, let's try iter again. Maybe I was just being stupid. No, yeah, there's a mismatch there. Iter. Wait, what am I doing? That's why it doesn't work. Iter. Yeah, so expected enum. Option link. Found struct. What did quick fix say to you? Nothing. There's no quick fix for this. Why isn't that values.iter into iter? Yeah, nah, because this what is this gonna return me? Let. Is there no iter for this? Into iter? No. Let's see what Stack Overflow says. So Rust implement iterator for a struct by iterating over attribute. Into iter maybe? Have we tried that already? Values into iter. Found collections, smash values. Yeah, this values thing kind of returns its own type, which is a values, right? And there is no iter for this. This is the standard library in Rust. Interesting. I'm looking to see if there's an implementation of the iterator here. So next or something. We have clone. No. Interesting. So what if we do something like a map? So map link IDs dot intuiter the map. What is this? What's coming in here? Yeah, nah, I don't want this either. I just want the link type. Oh no, yeah, this is links. So iter.map key and value, right? Ah, here we go, here we go. That's good. We're getting there. We just care about the values. And then can we do an intuiter? Expected up, so because of return type. Expected enum found hash map iter. Yeah, this is a lot harder than I thought it would be. What the hell? All I'm trying to do is, like, whenever you do a link graph dot iter, you will actually iterate over my links inside the link graph. Let's use ChatGPT, right? That's what it's for. Let's see if how good it is. And given a struct. Implement the iterator trait for the struct where it should iterator to the Let's see if this is gonna work. Yeah, this did it right, at least. Import my struct, your chat feed died, by the way. Oh, did he? Because I can kind of see it on the Thank you, let me see here. Oh, it's fine now. Ah, okay, cool. Maybe it was just for you, dude. Yeah, so this is kind of what I want to do, right? So it creates an inner into iterator impl a for a my struct. There's a lifetime there though. Now this is implementing the intuiter. Maybe I can do this as well though. I do understand this, but I kind of just wanted to implement the iterator, because if I'm not mistaken, correct me if I'm wrong here, this kind of copies it with a clone, the inner map, and that's what I'm trying to avoid, basically. That is what I'm trying to avoid. But oh well, you know, it doesn't seem to do that actually, so let's look at it. One thing I like about Rust as well is the lifetimes. I mean, that concept is new to me from Rust, in Rust at least. I don't think any other language has this concept of lifetimes, so it's It's kind of good. I kind of guess you need that if you have a borrow checker, right? Because you need to know when things live until and so on and so forth. So we want this to be the links. I find it cool and hard, yeah. It's the first time I looked at it and read the entire documentation, it was hard to understand, but you know, once you do understand, it's a little bit easier, I guess. So that would be a link ID, and that will be a link. Okay. What is the issue now? Cannot borrow self links as immutable because it's also borrowed as mutable. Oh no, my worst nightmare. 2 years of side projects in Rust, but I don't understand it properly. That's why I moved to learning C++. Yeah, in C++, you just do whatever you want, dude. There's no lifetimes. No lifetimes, but the compiler definitely won't tell you when an object dies. And then that will cause you a bug that will take you a week to fix by looking at it every day for 8 hours. I can count on my hand the number of times that happened to me. But so mutable borrow happens here. So cannot borrow as immutable because it's also borrowed as mutable. Will this help me? Cannot borrow a self-link as mutable more than once at a time. Interesting. And that's because I borrowed it. I guess. Where did I borrow it? First borrow happens here. First mutable borrow happens here. Yeah, I borrowed self. Now in Rust, this is the kind of shit I don't like though. When I get stuck in something that should be absolutely safe, like, because the compiler thinks it's not safe. So in my case here, yes, I did get a reference to a link from the self. And yes, I'm trying to, in here, get the parent ID, or a clone of the parent ID from the link IDs, right? But because I've already borrowed it as mutable before, it doesn't let me do that. Even though it's absolutely safe, because I am not actually modifying the link IDs in here. I am modifying, I guess I am modifying the parents there though. But yeah, but self link IDs is not, you know, touched at all. So this is kind of annoying in Rust. It's trying to make an overly safe program. The quick fix for this would be for me to drop link or something before, and then like it's a bit of a pain. I definitely don't want to get a mutable if I don't need to, so I can't borrow simple. I know when it was actually the other day at work, I was writing something similar to this and realized that I got stuck on something that's absolutely trivial in other languages. And this is kind of like one of those times. And it just makes me hate Rust a little bit. Like I'm thinking in my head, like, how do I do this without borrowing this self twice here? Even though this code is absolutely safe. Because the idea here is like, I kind of need self to get me the current link for the URL, or create one. This is what this function does. So it has to be a mutable reference here, right? It just has to be. But then in here, I also want to use the same self reference to check whether or not the parent URL already exists in my list of links. In other words, if I've already visited it, so I can get its ID. But it won't let me because it thinks I'm doing something unsafe. It's ridiculous. It's absolutely ridiculous. So contains key, I guess. No, yeah, we just want to get. We actually just want to get it. Why use self-link IDs? Can't you use the link from the line 18 rather than lin? No, because link IDs is a different thing. Link is a link object. Link IDs is, you know, a map with strings to link ID, which comes from self. But yeah. It's not as simple as that, unfortunately, in this case. And I hate getting stuck like this. Absolutely hate it. What I could do, right? I could kind of just self.link IDs. I'll get parent, I guess. Deconstruct line 22 into variables and see. What do you mean? So you mean like doing something like this, or self.link IDs? Is that what you mean? Okay, in other case, this is the issue. It doesn't let me borrow self. It's behind a mutable reference. What I could do instead is, I guess, I could... Does that work? No. Oh, yeah, sorry. I could kind of do that, but then this is where it fails. So if I try to use that now, what's going on? Yeah. This is the same error. This is the issue, basically. It doesn't let me do this here. Maybe clone it if it can. I would clone. However, this link IDs might be a very, very huge list. If you're talking about running this crawler for like a day, not a day, but say an hour. Yeah, this link ID is going to be like thousands of strings and IDs long. So I want to avoid cloning. That's the other thing as well. In this case, I want to keep the scalability a little bit. What I was trying to do is, like, maybe before I borrow it as a mutable, for sure, I can do something like, you know, let parent ID equals, or maybe self the link IDs, and I'll get parent get option, and then we still hold cloned. There you go. Now this is safe to clone. Yeah, maybe this is safe to clone. Just one link cloning here. And you know, the issue disappeared. So let me do the same again for the the children. So I guess, yeah, you know, in this case I can just move the order around. Don't know why I didn't think of that at the start. So I can do something like I can let the children, or the valid children. Yeah, cloning saves the day. Yeah. Cloning one object saves the day, yeah. I was trying to avoid cloning the entire link IDs though, which is what we did here. Children.map. And the knitter map. I kind of want to see if we do a self dot link IDs. I'll get child, which is an ID itself. Cloned. And instead of a map, I'm going to do filter map because I'm just going to keep the ones that are actually valid. There and there. So what do we have here? So valid children is, yeah, okay. I iterated to this now. I can get rid of this. And then down here I can say link.children.extend with the valid children. And there you go. This should be a little bit better than it was before. Why? And double reference, so let's clone it to save the day again. Can I borrow? No. Can I borrow self as mutable because it's also borrowed as immutable? There is something we can do. Let's just collect it into a vector of link ID here, or a vec. There you go. There's no reference now. No reference at all. Wait, what was the issue? Using clone on a double reference which returns string instead of cloning the inner type on by default. Instead of cloning the inner type by default. Quick fix. No quick fixes available. Am I really gonna have to Google this? Yeah, the issue is that I have a double reference and the get function takes a single reference, so roast turn str into str. That's what I want. STR is my worst enemy, yeah. I mean, I don't like it either. I especially don't like it when you get types like this, though, that make absolutely no sense. Like this type here, double reference to a string, right? This makes absolutely no freaking sense because string is already a reference. So why would the language Rust make a reference to a reference of a string and not automatically convert it to just a single reference? I have no idea. This is really what I love about Rust. Yeah, it's like a, I guess it's, yeah, it's what the guy said, is the iterator to a string, right? But yeah, I guess you can dereference it. You are quite right. Yeah, there you go. That makes sense. Thank you. I don't know why I didn't think of that. Thank you, Antonio. And then clone the whole thing, and then okay, cool. Right. So what is this? Methods update and force link are never used. Yeah, they are never used. They are never used. That is quite right. Find links is never read. Huh? How is link IDs never read? Which is intentionally ignored. Like it's read in here. So I guess it's because we don't really call this function. But oh well. Yeah, I mean we can change the main code now to use this link graph thing. Now let me just remember where I've put the entire thing though. Yeah, so basically what we're we're going to substitute is this link queue here, and oh sorry, the visitor links and the link IDs. So in essence, we just want public visited or link graph, which will be a read write lock of link graph, right? I can't actually see my keyboard, so I'm not in a good position. Link graph, there you go. So what we do want is use create serializer. Oh no, sorry, model. Why is link graph not? Because it's not a public struct, is it? There you go. What was I changing? Yeah, here. So we don't have these two now. We made it a little bit simpler. Of course, whenever we were using those two links, so link ID and whatever, which was in main from the looks of it. So the first thing is here. So visited links read.await. So I guess what I really want is that add link graph crawler state dot link graph dot read dot await. So if link graph, we have to implement length now, right? So no method name. Yeah, let's implement that shit, I guess. So pub fn len, which kind of takes in self, I guess, and returns a u size. Yeah, I can't spell size. A u size. And what do we return here? We simply return the self.links dot len, I guess, right? The length of the links. Of course, we don't do that. So that there is a len now here, and all the links found. I guess visited links. We can I guess print the link graph. Is it gonna let us? I feel like it doesn't. Yeah, it does. It does let us. Cool. Let's hope this is a quick refactor and not a long one. So get visited links equals crawler state visited links dot read. Again, we've established that we want this to be the links graph. Okay. We don't want that. We want this to be links graph here. There's so many to-dos here, it's insane. So find children already visited. We kind of done this already in the other file. I just put a comment here to update the children that we already visited into this link, and do the same for the parents. We don't need it anymore because we've done that today. Analyze the performance when we have all these locks being dropped multiple times. I'm gonna leave this here. until I find a benchmark measure, I guess, for this whole thing. Link IDs. So we want the link IDs. So what do I do with this link? Because I essentially, instead of calling the link IDs here with the new link to be updated, I call the update function that we have to simplify a lot of this logic. So that's kind of what I want. Which function is this? This is the crawl function. I'm holding a lot of locks here. Kind of don't like this, but what is this doing? This is getting the link queue with the right, getting the visited links and the link IDs. So essentially, you probably would have a let mute link graph here. Crawler state visited links dot right. I guess I'm gonna wait for it. Yeah, sorry for making this boring, guys. I know this is kind of boring, but it's kind of work that's necessary. We've got a link graph, and for each link in this create PowerPoint links, we're gonna see if we already have that in the queue. That's what we were doing before. So for every link that we got from the page, from scraping the current page, we were checking if we don't already have it in the link queue, right? So actually this is nothing to do with the link graph here. Link queue is here. So link IDs. So this check here is check if the link already visited, right? So that's kind of like one of the functions that we have to do in a link graph, I guess. So we kind of have a public function here, so pub function. Now we're going to return a boolean here. So what we actually want to do is we want to do a self and go into link IDs, log get, and then this URL. Right? And you want to check if it's some. Basically, that is it. That's what we want to do. The name kind of says it. So going back to this function here, what we want is to see the links, link graph. We want to do if it's not already visited, then we add it to the queue. That's what we want to do. Link ID visited links are gone on this instant. So we have like essentially like one less lock. I kind of like this change. There's still something here though. Link IDs. When is this being used? Find link IDs. Yeah. So this is kind of like what I want to. Like, can I drop all of this code? That's what we want to see. Something like this. Because this is the old way I was creating the links inside this crawl function. When I can just use that link graph structure now to do everything. So that's the idea. That's why we did this whole thing. That's why we came out of today's agenda to do a major refactor. So, okay. So if it wasn't already visited in the queue, add visited link to set. I've already visited links, add the value created link. Okay, so this is where I do it, right? This is where I call the link graph the update. And then I have the URL. Yeah, this is where I have the URL and everything else. So URL string. And then I've got the parents here, so where we kind of came from. Yeah, I wanna pass something in here, but for now we don't really have this value. The children, the other links that we found inside this link graph, which is scrape output links. Oh gosh. Is this taking a, yeah, kind of like a, I guess it is some sort of this and a, scrape output images, and then we've got a scrape output dot titles. That's it. Why is this not working? That's not a problem. We can change that. Okay. You happy now? Yes, you are. Yeah, so I'm gonna basically remove this. Let me just make sure that we can actually remove this. So link IDs, let's get in the previous link IDs, I guess. For the parents, we're creating an empty thing. Yeah, find link IDs. We know that we no longer need this function as well because it's done in the other file. So we've got it up here, and yeah, I think it's safe for us to remove this. You know, or at the very least, comment everything out. If there's any logic that we're missing, we will see. Visited links and so okay, yeah, that is it, guys. That was the big refactor. Now, of course, we've got some other shit here. So link graph. Do I have a default type for link graph? Because I will now. That's better. So link graph default. Trait bound is not default, so that's fine. The trait default is not implemented for link graph. Returns a default value. Like why? Consider removing the reference. Okay. Change things a little bit. Like, why is the trait default not implemented? Borrowed of moved value links up here. Ah, yeah, I didn't want to move this. Can I just do a knitter instead? There you go. Then we don't move it. And we only clone the ones that we actually want to clone. That's better. So what is this logic? This is in the try main. What do we do here? So visited links. What do we do with this? Convert links to images. Oh, at the very end, let's see what we do. So at the very end, we kind of convert all the links to a list of images to download them. Okay. Yeah, let's change this. So let link. What is this? So we've got visited links, we don't really care. Why do we have a new client here? Oh, yeah, because we don't want to download the images, that makes sense. And what does this one take? A hash map of link ID to link. So this is simply, let's change that. This was going to take a link graph now. And there will be a use types here. Intuiter. This is where the intuiter comes in. That's why I wanted to do that, because I knew it was going to be here. So thank you for helping me out. So the link itself. That's what I care about. Cool. The rest just works, right? Serialize links. What is this? Okay, so in here again, I'm going to take the reference to the link graph. This is going to say that we don't satisfy the serialized trait, right? So yeah, let's do that. No worries. And this is where we need the Serde serialized there. Is this happy now? Yeah, it seems to be happy. There are another couple of things. So we're going to take the link graph as a reference to an immutable there. And then there's another one here. So serialized links, link graph in here too. So good. Are we not using either of these? We can remove, no problem. What is the issue here though? Unused result. Crawler loop. Yeah, see, this is something I don't want to just put a question mark there, because I don't want the error to cascade. I kind of want to do a match on here really. So match this, and if I say it's an error, or in fact, and if let error equals this, I want to say it's a log error or something. Could not update the link graph with there you go. A little bit better now. Are we ready to compile this? Because it should compile, of course. But are we ready to format? Let's do an FMT. Fucking hell, a lot of things change here. Are we also ready to run cargo clippy? Because there will be quite a few issues. Yeah, there you go. Told you. I always make static analyzer issues or errors. So we can remove that. Bring me to the next one. What's the issue? Implied clone of type U64 implements copy. Okay, so I guess we don't need it. Try dereferencing it. Very good point. On to the next one. I love cargo clippy. Yeah, so do I. Because it tells me whenever I do something stupid that I should have just done in a better way. Wait, what's the issue? Yeah, just new link. Help change this to... Hey, we've also got this on the pipeline now, right? The pipeline that we did yesterday. So when we push it, it should work. So, okay, so what's the issue? Help change this to link. Okay, I'll change that to link. Now, because we changed a bunch of things, we have to rerun cargo FMT maybe. And okay, that's better. So I'm going to change the cargo lock up until the 7th file. And what's very interesting is that we should have a pipeline running now, right? So there you go. Beautiful pipeline. Cool. Now, does it work? That's the question. Does it work? So let's see. I don't have a debug file here. That's fine. So if I go to target, first of all, cargo build. Oh no, it's rebuilding all my dependencies because I removed the cargo lock previously. Not ideal. Oh, there's MIO here somewhere. Memory mapping. If you guys got any ideas of like cool things to do on stream or to look at, please let me know, because I kind of run out of ideas sometimes. I was talking about getting motivated earlier in the stream, and that's one of the things that drags me down sometimes, like having no good ideas. So either for like videos or like live streams, and scripting. Yeah, that's something I want to look at. So that's a good idea. I'm definitely gonna maybe stream that this week. Well, I'm not sure this week because I'm not streaming tomorrow, so maybe on Saturday. Yeah, the thing with streaming on Fridays is that no one's really like out and about. On Friday, everyone's like out with their friends and stuff. I got a dummy repo I found. Dude, you should link me up. If you send me on Discord, I'll take a look at it, and then maybe we can start from there. So WebAssembly, right? WebAssembly is just used to control the DOM objects, right? Kind of like JavaScript, I guess. Binary code format and corresponds text format for executable programs, as well as software interfaces. Like I've never really used WebAssembly before. I know people use it for like WebGL and stuff like that, and controlling like DOM objects. Is it actually that much faster than JavaScript? Out of interest. Sounds like a fun stream idea, yeah. I'll definitely do that, dude. Like that's one of the things I need to learn. Scripting. I have read this project before, like I just never got to do anything with it. Yeah, but you can use OpenGL on C++. Yeah. So that's how I've seen people using it. So like you've got usually like a game online where you've got like a a canvas, right? A HTML5 canvas with WebGL in it, and then people would write C++ to control the WebGL inside it. So, but people also use it for like web frameworks, right? I'm not sure how much faster it is. Like, is it? That's what I'm interested in. Is it like, is WebAssembly faster than JavaScript? JavaScript is much slower than WebAssembly when processing a large amount of data is involved. I wouldn't say much slower, you know. I mean, it's not even double faster. Because usually, like, if you compare a C++ program compiled for, you know, for a native platform against the same JavaScript tool, it is like 100 times faster usually, like 60 to 100 times faster. But I guess it's getting there, right? It needs a lot of optimizations. It is faster though, however. It seems to be, you know, relatively faster. That's what I'm saying. But not a lot faster. Not like 10, 20 times faster. That's what I was expecting. But it's C++ on the web, yeah. It is C++ on the web. Right, so now, target. Why is target debug not there? Target debug. Oh yeah, because there is. Yeah, there's something definitely wrong. There's something definitely wrong. I know, it does seem to work though. It's getting the titles and everything, which is interesting. I should use them, and it's also getting like a lot of bullshit in them. Okay, let's take a look at this. Thank you for the link. This is so annoying, but like, I cannot copy. Oh gosh. Okay, yeah, I'll copy everything. Just wanted to show you my annoyance with this chat box. I got a big, beautiful picture of Vladimir Putin there. Oh. I guess this is your repository. If anyone found this here, I have a question. How can multiple... I love this. If anyone found this here, I have a question. How can multi-threading be activated in Emscripten? That's a good question. That's a good question. I know some guys. Alright, alright. So it's got VC package, running with VC CMake lists. I like taking a look at the CMake lists at the top. Usually gives you a nice idea of how things are laid out. And execute voice. EM. Oh, it's got an EM GUI. Oh, he's compiling EM GUI for the web. I like that. And he's using VC package along the way as well. But the thing is, how does he set the toolchain file? I mean the compiler to be Emscripten, right? Because you usually have to write a toolchain file. So I'm guessing he has a toolchain file or something. Make the build. Ah, okay, so Emscripten has a CMake binding or something, I guess. Oh, he has an SDK. Cool. I will try, man, but I will try it on another stream. I'm gonna save it here. On next stream, I'll definitely do some Emscripten, right? Thank you for the idea. So that will be next stream's idea. So this is probably a good place to start. Or even just the get started guide on Emscripten. But I like this because it already has imGUI on there. So I'm definitely gonna make use of this. Going back to this, what is going on here though? Oh, max links was 10, that's why. RF images. I just want to make sure this still works. So if we do still like 100. I didn't actually get to the, could not find links. Okay. Didn't get to the main thing that I wanted to do today, which was to essentially, gosh, there's a lot of titles and things and stuff. To essentially write a serializer for this, because at the very minute, I think we have links.json there. So if we open links.json, for example, what does it look like? Links.json. Where's links.json? Where is there? Oh, here. So we've got this file, but we still have the same problem where it kind of just, oh, we need to escape these strings as well. Maybe confused with ASCII character, that. Yeah, we need to make a serializer that doesn't just load this whole thing into memory, because it's loading everything into memory and saving it. But oh well. This is cool. I want to see if my children are getting updated eventually. See, they're not. So I've broken that. I've somehow broken the children. No, I've broken the children. And I've broken the images as well. So great, great. Great refactoring. We broke everything. That's okay. I can probably sort this out next time. But the URLs are working and the titles are working now. That's kind of what I care about. So cool, cool. Yeah, guys, I'm gonna, as usual, I'm gonna call it right here because I kind of need to go to bed soon. So I'm gonna. It looks pretty, yeah. It looks, Antonio, it looks pretty, but it doesn't look right. That's the point, because I definitely had some children before. Now we're getting 0 children everywhere. And we also have no images, right? They should be showing here. Unless I've broken that, which, yeah, which I guess, you know, could be the issue. But I'll figure it out before the next stream. Unfortunately, yeah, I broke that and I broke the images because they're not being saved either. I can see it here. But anyway, I'm gonna call it a good night here because I have to work tomorrow morning. I'm gonna get up a little bit earlier as well to do some work. And thank you both for joining, by the way, Slim and Antonio. And I guess I'll see you guys maybe on Saturday if I do end up streaming. But if I don't, have a good weekend, guys, and don't forget to learn a lot. It's a bit cheesy. Yeah, have a good weekend, and just hope you guys get to chill out. Take care. Bye bye.